So I hope it is visible, ma'am. Please acknowledge once if it is.
Yeah, it's visible, sir.
Okay, so a very good afternoon to everyone. Myself, Dr. Abhishek, and most of us are, I mean, almost everyone of you as my colleague, and we all are from same community. So I'm really excited and really looking forward to collaborate or to work with you and for this session also. So let me share this PPT, and once we will have some discussion, then we will have a hands-on session also. I have made some, I mean, two different codes. One is showing normal AI, and one is showing neural network along with Gen AI using GAN, adversarial network, and those things. So let's discuss it. Like it would be a more interactive session. So I would request Ranisha ma'am to do a question or session after my session has been done.
Yeah,
So
sure, sir.
let's start with it. Slide is introduction to generative AI. Why generative AI? So let me tell you in a very simple way. You know, let's start with very simple example that what is Gen AI. So why, if there is a AI, what is why Gen AI was needed? So on the given slide, it is given that there are three points that I want to discuss. That learning from a data. So let me tell you, learning from the data is also a feature, one of the feature of general AI, and why it is opted in generative AI. Fine. The second thing, creative new sound. So if it is about audio synthesis, if it is about video synthesis, in both the cases we have to work on the data, the probe data we are having. So creating new sound was very much opted in simple AI, which AI, the conventional AI, which has been in use since long, since we have started our study, since we done our PhD, and since our previous generation did their PhD and research work. Fine. So basically, Gen AI, according to me, or according to the experiences I have gone through with, Gen AI is having versatility. Gen AI is having adaptability on the basis of learning of the data. At the same time, it is having a dynamic environment to explore more itself. Like if it is having a data that you must remember, like what is supervised learning, what is unsupervised learning, and then what is reinforcement learning. So let's discuss reinforcement learning. Reinforcement learning is learning from your own experiences, reward and punishment. So if domesticating a dog or feeding a child with a spoon, that too could be the example when we are dealing with the reinforcement learning. So every time we are asking a dog to come for a biscuit, and it is taken by that particular dog, we are giving reward, that very good, that kind of thing. And if it is not obeying the order, it is getting punishment, that ignorance or something like that. So it is a very much a Google example, or very much available on different websites, like what is reinforcement learning, how it is getting done, what is the example of reinforcement learning. So let's discuss it sometime, like in the end of the session. I would like to ask any of you if would like to answer it, that what is the difference between Gen AI and reinforcement learning? Both are learning from data. Both techniques are learning from data. Both are giving punishment and reward. So why Gen AI? Fine. So generative AI models are trained on a large data set, and it could be like audio samples, it could be text, it could be video samples, but we are supposed to perform everything on audio synthesis, because it's an audio synthesis talk. So we will more discuss about audio only. So allowing them to learn pattern and characteristics of sound. So the coding will also, you know explain or illustrate the part of sound, how sounds is getting generated, and how sound is without getting generated without emphasizing on that specific pattern or a specific rules. So Gen AI is more like dynamic. It is not based on a specific rules, it is not based on a specific pattern. it is having a vast explorance, and on the basis of those data learning, it is explaining the things to you, which is somehow very much relevant to the topic or to the question you are answering, you want the answer for. So my point is, the perfect example of Gen AI could be like Chat GPT. uh, it is a perfect example. Like, it is never a perfect answer for all the questions we have asked it for, but somehow it is very much relatable, and somehow it is very much relevant, or somehow it is very much near to those answers. When it was launched in 2021 September or November, I'm not getting it right. So it was having data till 2021, but in the paid version now it is having the data till date. Fine. So it is a best example of real time Gen AI, and there are lots of others. So even if you have to generate image, even if you have to generate some fake audio, even if you have to generate, you must have heard about deep fakes nowadays. So most probably in animation, in movies, these are very much applicable. Fine. So now the third point could be like, generative AI could have applications including music, sound design, speech synthesis, and more. Fine. So this is the introduction. We just need to go through with this, and now let's move to the next slide. Like, model learns audio pattern from large data set, right? And what could be the creative potential? The creative potential could be generate unique sound and music again and again. So that is the first case, like waveform generation. So generating a specific type of waveform, like sine wave, square wave, sawtooth waves, including many conventional approaches. Fine. Then we are having signal processing. So if we are applying some filter effect that we will see in the coding part, and other processing technique to manipulate the shape of generated sound. Fine. And finally, the topic is aptly justified, like what is synthesis? So how synthesis technique will be opted. So employing methods like additive synthesis, subtractive synthesis, FM synthesis, frequency modulation synthesis, to create complex sounds. Fine. Just to create it is not audio synthesis. It is all about to create, insert, extract, and manipulating it in many other ways. Fine. So the fundamentals of audio synthesis is, before getting into fundamental of audio synthesis, we must need to how we will create potential. Fine. So we can create potential by generating unique sound and music first. Fine. Then what are the emerging technologies we have to focus for? Like rapid advancement with significant potentials. Like I've told you, like employing methods like additive synthesis, subtractive synthesis is too much conventional. It's too much classic now. So we need to make some hybrid model to create complex sound for those extracting the sound, or for those inserting the sound, or for manipulating overall performing the audio synthesis. Fine. So I hope this slide is clear to all of you, like how we are making a flow of content just to understand why audio synthesis is going to be done, what is the need of audio synthesis, what is audio synthesis, and how Gen AI is making a difference to it. Fine. Now, a very important slide, which will make the base of the session for this time, like generative model for audio. Fine. So first one is VAI. Then we are having. I have just discussed GAN. Then I have just discussed transformers. Transformers is yet to be discussed. So if we are having VAEs, like variational autoencoder. So being a person from CSC, I'm very much not into it, but how Gen AI is applied over it and how we are calculating all those things, I'm very much aware of. So VAE basically compress and generate new audio from the representation, isn't it? So learn a compressed representation of audio data and generate new sound by decoding this representation, what it is written over here. But it basically compress and generate new audio from the representation we are having. Then we are having GAN, Generative Adversarial Network. So if we are talking about generative adversarial network, we do have neural network associated with it, and then we are having those learning and training module also. As much as it was in classical approach, it is as same as there also. So what is written on the slide? Let me read it out. Then I'll explain it to you. That GAN consists of generator network that creates sounds, and again the learning period is creating sound, that creating a data, fine. And then we are having a discriminator like training. So discriminator will discriminate network that evaluates their realism, like training it to discriminate between x and y. So suppose we are opting for x, so it will always discriminate between x and y. That is the whole case. So in summary of GAN, we can write that generator creates and discriminators evaluate. Fine, only two lines. Generator, which is a part of like learning. So generator will create it, generating data, and discriminator will always help to evaluate realism. That suppose we are supposed to find some one class out of two classes, so it will always give one class. Now we are having transformers. So what transformers basically doing, like, so transformers excel the capturing long range dependencies in audio data and leading to more coherent means more robust, fine, more coherent, more nuanced generation, fine. So you can say this like wavenet. If we are talking about transformer, so it generates detailed audio most probably by modeling temporal dependency. So coherent means temporal dependency. So if we are modeling it to temporal dependency, then only the system would be called like coherent. So generative model for audio generation is this only. Means if we are covering this particular part, all these three, so we are covering generative model for audio generation. So it is basically not for generation only, it is also working as discriminator, which is GAN, fine. And again the transformer part, let me tell you, webnet is the example. So generates detailed audio, and at the same time it is modeling it for temporal dependency. So this is the story of this particular slide. So let me go back and let me tell you like introduction to Gen AI, fundamental of audio synthesis, and then we are having how generative model works for audio, and what are those terminologies and techniques we are using for it. So I hope these slides are clear to you, and if not, just write down your questions, we will discuss it in the latter phase. Now we are having applications of generative audio, music, sound design, and beyond. So uh, before getting into implementation of generative AI in MATLAB and performing data preparation and model training and audio generation. So because it is Gen AI, we will use some inbuilt data or synthetic images we can use, or any random type of audio data set we can use, just to show like how Gen AI is working and how normal AI is working. So before getting into this, we just need to perform like how application of generative audio and music, sound design, and beyond are going on. Like music composition is the first example, sound design is the second example, and the third one, which is mentioned over here, is a speech synthesis. So generating melodies, harmonies, rhythms, or even entire musical pieces. Like, let me give you an example from South India only. A music director, if you are aware of the movies, they were, or the music directors, they were having the Ilya Raja was the previous music director, not using autotune because it was not there, and now he's one of the disciple like A.R. Rahman is working superbly on different music composition and working, having different sound engineers to work for sound design, fine. So they have won Oscar for that, like Slumdog Millionaire. I don't remember the name of that sound designer, but he is working with A.R. Rahman only. So this is just an example which struck into my mind, and I'm just discussing it with you. So if we are talking about music composition, just generating melodies, harmonies, and rhythms, or even entire musical pieces we can perform. So if we are going for sound design, so create unique and realistic sound effect from movies. It could be from movies, it could be from games, It could be from other media we are having. Now, how is speech synthesis is going on? How we are doing speech synthesis? Suppose I have just discussed it with you. We are performing data preparation. Fine. What we are doing in data preparation? Organizing data set for training, right? Then we are having Gen AI, which is having a class of generator and then having a class of discriminator. So before getting into the class of discriminator, we must have to go through with the model training. And what model training is doing? Train model using deep learning tools or using any AIML tools. Then we are having audio generation, which I have just discussed on the uh, upper part, like music composition and sound design. Like customize the parameters for creative audio inputs or outputs. I beg your pardon. So customize parameters for creative audio outputs. So in the process, generating synthesis voices for text to speech application and virtual assistant and more comes under the category of speech synthesis. So if you asking me, or if you are thinking to summarize this slide in 3 points, that we are implementing Gen AI in MATLAB or Python. I'm very much quite savvy with MATLAB. So MATLAB. So data preparation is one, model training would be the second one, and audio generation will be done, and then speech synthesis can be achieved. So these are the three processes only, basically. Fine. So if it is about application and use cases, so we can say that music composition, generate melodies and harmonies. Then we can say sound effects, create immersive effects of games and media, like I have explained in the second part. And how speech synthesis is achieved? When we are producing realistic, natural sounding speech. Now you are very much relating to this fact, like produce realistic and natural sounding speech. So you cannot really evaluate or discriminate between the natural sounding speech and realistic speech, which is faked somehow and which is done with the hybrid method and which is not very much original like before. So that's why audio synthesis is very much important nowadays, and we are doing it on a large scale. So, what is the conclusion part? Like conclusion, and what could be the future direction of this? Fine. So, before getting into conclusion and future direction, we must need to go with the what could be the challenges and limitations of generative audio. Fine. So, first of all, let's get back and let's discuss what is error, what is noise. So anything which is not intended is error, and same application or same definition will be opted for noise. Anything which is not intended. It's not necessary that there is a book of computer network. In that particular book, there is an example that in a room of 10 people, all people are from different countries and they are speaking different languages. So whatever they are speaking themselves, like Japanese, Chinese, and Indian, or any other languages, it is noise for the other person. Fine, because it is not intended for them, it is not meant for them. Similarly, if you are adding 3 and 2, and it should always give 5 answer. Even you are applying flooring or ceiling function to it, like 4.99 or 5.22 would not be a precise value. Getting my point? So the challenges and limitations are not limited. So first of all, the data requirement is the primary challenge we are having. So data requirement means generative model require vast amount of high quality audio data for training. That is generator part. I have told you now that if you are applying Gen AI, so you have to apply Gen, adversarial network. Using neural network only you are able to apply it. Fine. And if you are applying it using neural network, you have to perform data generation. When you are performing data generation, data preparation, so it is a very huge challenge that how we will organize those data sets in a very organized manner for training. Fine. And how all the data sets and all the data into the data sets should be of high quality, and how it could be trained. So generator part is a very crucial part to take care of. Now control and predictability. As if we have discussed before, that fine tuning generative model to produce a specific sound with desired characteristics can be challenging. Means if you are questioning for what is an apple, so certainly ChatGPT or Gemini AI will give you that it is a fruit. It is uh, it is very much found in the part of India, in Kashmir or Himachal. That could be the very generic answer. But which green apple is found in which part of India, or red apple is found in which part of India? Now it is getting stuck. So we have to generate data like that only. Means it is not very complex part. The person who has been practicing AI and ML, they have been doing this. The data requirements has always been a problem. So the same problem would be here also. And if the data requirement is a problem, then control and predictability certainly would be a problem. We cannot overcome with this without having proper synthesis part. So that's why audio synthesis is important. And how it is important with generative AI, and what could the difference it could make, that it is having a dynamic environment, it is having an adaptability feature with them. Fine. So innovation could be one of the challenges also, that advancing a model architecture and method, that how you will advance it, how you will fine tune it to get a good result, how you will provide the predictability. Fine. So creativity, that how you will unlock new sonic possibilities, like how you will perform it. Then what could be the future potential, like personalized and interactive audio experiences could be the future experiences, that you can generate any synthetic audio or any kind of random audio, and you are just about to operate it and predict it from the data you are having. So this could be the uh, future direction that could be work on. Fine. So if we are talking about transformative technology, like how it is working, so how sound creation is getting changed, and how its consumption is getting placed, then how, what could be the endless possibilities, like fostering creativity across industries. Industry application is one of the most important part that we should focus on while doing any kind of AI application or ML application. If nobody is finding it good enough or feasible enough for the market, there is no point in doing this. Fine. And then certainly there will be a continued development, like constant advancement in audio synthesis can be done. So whether you are using explainable AI, whether you are using generative AI, whether you are using ensemble learning, that you have to check with it that the data you have created, or the data you have generated, or the requirement of the data you are having is pretty much compatible with those particular algorithm or not. They are okay to the audio data or not. They are not supposed to opt for textual data only. So now a very important technique, now after going through with the details, we are now having introduction to the generative AI techniques. Fine. Sorry. Let me share it again. Yeah. So as I have discussed with you, there is a point called data preparation, model training. So for model training, I have kept it deep learning models. Fine. So Gen AI relies heavily on learning models. As I have told you, that compatibility part. Fine. So particularly generative adversarial network (GAN), and that is variational autoencoder. So these are having very good compatibility with deep learning models. So Gen AI is having a very good tuning with these particular techniques. And how data driven approach can be useful. So I just told you in the first slide that data driven or data driven techniques or data driven predictability was priorly there with the normal AI. But why we should opt for generative AI? So these models learn from massive data set. Massive data set of what? Massive data set of audio structures also. Fine. So audio generation, I have just explained to you in the previous slide, that to customize the parameters to create a very good audio output. Fine, not input, output. Input has been created, and now we are into data driven approach. So how you will create control? So this is the last point, like creative control. Generative AI offers creative control by using allow users to for the generative process. You know, I have just discussed with you that transformative technology. Fine. So if we are creating new sounds, suppose if we are creating new sound, then what points we should keep in our mind? So model generate innovative sound. How it should resemble? It should resemble training data, but with unique creative variation. If variation is not there, there is no point in using expensive techniques. And when these outputs expand possibilities for music, effects, experimentation, fine, then only it could be termed as like we are creating a new sound. How we are doing learning from data? So generative AI model analyze large data sets to understand pattern and characteristics of audio. Agree with me? And this enables the generation of new realistic audio based on the learned features, which has already been learned. That's why I have discussed with you GAN, which is having generator and discriminator. So if we are able to understand generator and discriminator, lots of things will be cleared to us. Fine. So if we are into application of Gen AI, it is widely used in music composition. Widely. That's why we are using it for the synthesis, like sound design, speech synthesis. So it is mostly applicable along entertainment, assistive technologies, and content creation industries are mostly using it, as we have discussed it with you. Fine. So if I am discussing, like, focus on these two parts, like GAN and VAs. So generate sound by decoding compressed data is used for variational autoencoder. What variational autoencoder is doing? It is generating sound, and at the same time it is decoding the compressed data and generating the sound out of it. What is GAN doing it? Again, the two techniques like discriminator and generator. But how it is doing? Combine generator and discriminator network for realism. Then again, what is transformer is doing? So it is handling long range dependencies of coherent videos or audios you are using. Doesn't matter whether videos or audios, but audios may be of small size, so it is handling long range dependencies. Fine. For what? For coherent audios. So if this particular slide is clear to you, now we are able to understand what is the fundamental of audio synthesis. Fine. The same synthetic techniques we will go through with, the signal processing we will go through with, and waveform types we will go through with. Fine. So this is the application I'm talking about, that application of generative AI in audio signal synthesis, like how it is working for it. Fine. So compose melodies and harmonies, as we have discussed. We should not get into more details again, because I have already discussed this slide in the previous only. Now, speech synthesis part. Focus on the rightmost part. How speech synthesis is done. So, generative AI model can synthesize realistic human speech, enabling more natural sounding voice assistance. Audiobooks, it could be Cuckoo FM is there, and personalized communication. Fine. So, it is very much useful for speech synthesis. Fine. Now, if we are talking about speech synthesis, we are having three fundamentals in our mind. Waveform types. What could be the types of waveform? Like generate sine wave, square wave, sawtooth waves for sound creation. And if we are doing signal processing, we should apply filter, as I have discussed in the second or third slide. And those filter effects for enhanced sound quality for those particular audio signals. Sorry. And now for the speech synthesis part, we can use additive, subtractive, and FM synthesis method just to make sure that it is going to be done effectively. Fine. So this is the whole story of application of generative AI in audio signal synthesis. Now, a very important part, that how we will explore MATLAB capabilities for generative AI or generative audio. So we could have some prerequisites like audio processing toolbox should be there. Deep learning toolbox is not coming with the 2024 version, so we need to download it and integrate it with the MATLAB tool. And MATLAB supports all various open source libraries like generative audio such as TensorFlow and PyTorch. So we need not to have those TensorFlow and PyTorch. We generative audio can be supported by MATLAB only, and we can see it like how it is getting done. Fine. So let's discuss the case study first, then we will discuss the different other things. So when we are talking about case study, music composition with generative AI, so again, you can see that whatever we have discussed before are the base. So it would be there only as far as data preparation, generative process, and post processing is concerned. So let's just start with the data preparation. Fine. How data preparation is getting done in Gen AI for audio synthesis. Fine. So the second part is generative process that use the trend model to generate new melodies, harmonies. The same thing I've repeated. What will happen? The previous concept we have discussed will apply into the case studies now. So how we will do for music composition with generative AIs. Fine. How it will be done. Fine. So if we are talking about data preparation, the step involves, just now I have explained what is noise. Suppose I am taking this lecture and there is a noise from the fan is there. So nobody is intending those fan noise. So that is a noise. So cleaning is the most important part, you know, and then cleaning, formatting, and structuring data to make it suitable for the use for model chosen by generative AI or technology. Fine. So this often includes preparing a data by processing and embedding it into vector stored database. That is a different thing. We won't discuss it. Fine. For now, we need to understand that data preparation will involve cleaning, formatting, structuring data to make it suitable for or to make it compatible for Gen AI models and technologies. Fine. So the post processing part is fine tune the generated music, add human touch, and arrange it to the complete composition. How it will be done? Fine. How it will be done? If we are talking about Gen AI for music synthesis, how post processing will be done? Data preparation is the pre processing. But if we are talking about post processing in Gen AI, then when we are getting the final results from the generative model we are having, that second step, just look at the second step, use the trend model to generate new melodies and harmonies. That has already been done. We just need to fine tune those generated music and add human touch into it. Fine. So basically, generative AI powered speech to speech technology is forever changing the way we communicate. Getting my point? This groundbreaking innovation enables real time transformations from one person's speech to another's voice and even different languages. Netflix is one of the example. Prime Video, Amazon is one of the example. Particular thing, and it is not the real audio from that particular actor or actress. Fine. So opening up a world of possibilities from enhancing customer service experiences to creating immersive gaming environment. So that could be the case study. Fine. Now case study 2. Again, case study 2 is sound design with generative AI. How we will design the sound with generative AI, like data collections, model training, sound generation is there. So before getting into the terms which we have depicted over here, we could have a very a proper discussion, like how we will enhancing it from customer service experiences to create immersive gaming environment, and even adding law enforcement into it. The potential application of voice technology is getting vast. So whatever the recent advancement can be attributed to the modulation of machine learning algorithm, we have just mentioned the deep learning algorithm. But the basically when it started off, like, we have to perform the maturation of machine learning algorithm, extensive and diverse data set availability, that is data collection, the first point. Fine. Now, the increasing computational cost first and computational power that support the sophisticated models that we are using, deep learning models we are talking about. So, despite this advancement, challenges persist. We are already stuck into it. We are not making it the final change we have made. Like, this is not the final answer. So, model training is in itself a very big challenge. So train a model on the collected sample and to learn their characteristics and pattern. You know, these things, so let's explore the current landscape of generative AI, speech to speech technology. Fine. So the evolution of speech to speech technology has been remarkable progress. Fine. Early attempts produced unnatural outputs. It has never been easy. But advanced technologies like I have just discussed with you that neural network, so recurrent neural network, RNN, GAN, generative adversarial network, and now enable high fidelity speech transformation, capturing the nuisance of the human voice. And now it is getting done much better than before. That is what sound generation is all about. So these deep learning, like, maturation of ML algorithm was not good enough. So these deep learning architecture have become adept at the modeling of complexity of the speech, first point, including tone, pitch, and cadence. And at the same time, as a result, modern AI speech to speech system can generate remarkably human like outputs, means opening up new possibilities in the area of audio synthesis, language translation, voice assistant, accessibility tools for individual with a speech impairment, kind of. So this particular case study is all about that part. Fine. So this was the first case study, and this is the second case study. Now the challenges and limitation. Generative AI overcome the problems which AI/ML algorithm was having before. Now generative AI is also having those limitations and challenges and limitations. How we will see to it? Data bias. Model can inherit biases from training data, as we have discussed it before, so leading to unintended stereotypes or limitation. Unintended value, remember I have just told you. So you have to get it from there. Leading to unintended stereotypes or limitations could create data bias. Fine. So generative AI, perfect example could be GPT-3, Google's T5. So these models initially designed for a language generation, remember, and have been successfully adapted for a speech to speech task. So leveraging vast amount of text and audio data to produce highly accurate speech transformation, you know, so that kind of advancement must come with the challenges and limitations we are having. So there must be lack of control if you'll go through with it. Data bias could be the one, lack of control could be the one. So generative AI often lacks precise control, like you cannot have a precise value out of it. you know Generated outputs making it challenging for achieve a specific creative goals, like 3 plus 2 we need 5 only. Fine. So such kind of concepts. So I want to discuss with you some advancement along with how those advancement has been achieved, what we have done to get those advancement. So before getting into this, we will must have to discuss that generative AI inspired
Hello, sir. Sorry for interruption. Your slides are not visible, sir.
Ma'am, is it visible now?
Yeah, yeah, it's visible, sir, but PPTs are not visible, sir.
Okay, wait for a while.
Hello, sir.
Lecture, ma'am. Ma'am, wait for a while.
Yeah.
Yeah, please.
Yes, ma'am. So, should I proceed now?
Yeah, yeah, you can, sir.
Okay, ma'am. Thank you. So we were on challenges and limitations. So what could be the future direction and conclusion? Uh, developing more. I have just discussed like what could be the future development. But before getting into future development, we just need to, procedural design. We just need to discuss like how it is used and what could be the consequences, what could be the advancement we could provide. So basically it uses algorithm and rule based approaches. Previously what happened, only rule based approaches were using to build music dynamically, more dynamically than before, and it would be certainly AI driven creativity. Fine. So when you are performing generative AI or something like that, let me show you with an example. Let me get out of this and let me share this tool. Ma'am, is it visible?
Yes, sir.
Okay. So let's go through with the first part, like how audio synthesis is getting performed. So without using Gen AI, without using neural network, so we do have like defining a sample frequency. First of all, we have just defining a sample frequency fs with this particular thing, which we are teaching to the undergraduate students. Then we have to perform that simple sine wave. Fine. Why we are doing this? We are just displaying message in command window, and we just need to create a time vector. Then we have to create a frequency for that sine wave. Then we have to generate the sine wave using sine function. So this line is particularly meant for this. I'm selecting it. Just have a look over this. And now we have to play a generated sine wave sound. So we just need to use inbuilt function sound, and we have to pass that sine wave in which we have taken some values, and we have to pass that fs in which we have passed that value. So we have to pass that sine wave with respect to fs only. Fine. And then we have to perform that a pause for 1.5 second. It could be anything else. You want to do any changes, you can do that to allow a playback before moving to the next example. Fine. So this particular thing we are having for simple sine wave. So why we are doing this? We are doing with a sampling frequency. So we are performing audio synthesis demo, fine, which is very much classical synthetic techniques with that had been used in audio synthesis techniques. Fine. Now we are supposed to perform the major code, display a message in a command window, something like that we have to do. So now we are having time vector for 2 seconds. So we have just finished that particular part. And now we have to set that frequency C4, E4 and G4. How we are sending it? So some random values we have taken for the frequency part, because there is no upper threshold and lower threshold, something around anything which we have take. Then we have to generate again a sine wave for each node and sum them to create the chord. Yani, means we need to make a hybrid sine wave, and we have to particularly store that part in the chord part. Fine. Now, how we will normalize the things? Before, we used to normalize the images, like we have to make it black and white, like only 0 pixel and 1 pixel. So what we will do over here, normalize the code by prevent clipping. Fine. So absolute value of the code and the maximum value of the code, and the chord is divided by the maximum value and absolute value of the chord. As clearly it is written over here, the scale values lies always between -1 to 1. Fine. Now we have to say that play the generated chord sound. Play the generated chord sound. That sound, chord and fs, we have explained it over here in the first line of the code. Fine. And then we are having noisy sine wave. We are having a particular very normal sine wave, a sine wave with the frequency values. Now we are having noisy sine wave, just to check with it that whether we are creating a time vector of 2 seconds and generating a sine wave. And when we are adding random noise to particular sine wave, which is having some scaling values, now what will happen? So play the noise sine wave sound. So first of all, a simple sound wave sound, then generated chord sound, and then uh, a simple noisy generated sine wave sound. Fine. Now, as I have told you that we have to generate it, we have to perform video or audio synthesis. So we will have to go for like sawtooth wave, square wave, and those kind of additive or subtractive wave. Fine. So we have just taken sawtooth wave just to make it more compatible. And we have performed this particular sawtooth wave with inbuilt values, with predefined values. And now we have compared it with respect to the fs we have set before. And we want it to be a pause of 1.5 second. The time you could increase or decrease as per your convenience or as per your prerequisite data. Fine. The same thing will happen with the square wave. What we will do with the square wave, the same thing will be happen. Fine. Now we are having amplitude modulated wave. We are having formula for this. Nothing needs to be changed, like amplitude modulation, same formula. Fine. And now we have to amplitude wave sound as compare or with respect to fs. Means nothing we have to change. We are just generating, or we are just applying different modulated wave, and we are getting it implemented with respect to fs we have discussed. And then it is having a pause of 2.5 second. The pause time could be increased or decreased at the same time. Now fm wave we are having. So same thing we have done, displaying the things, and we have taken a pause of 2.5 second, and we are generating this graph also as compared to fs. Fine. Now this is something new, like white noise. And we are doing it for what? We are doing it just for the sake of demo, like how it is working without Gen AI and how it will work with Gen AI. Fine. So if we are talking about white noise, some random function has been used and some duration has been integrated, and then white noise and fs has been done. Fine. So similarly, we can use for beating effect, we can use for simple melody. Fine, just like that. So I've just made this code. If you want this for teaching purpose or something like that, so I can share it with you, or you can take it from my website also. We just need to run it and see how it is working. See how it is working, how it is taking a pause. just to run this code fully. It's done. Let, we will check it later, like if it is having any error or not. Now, the most important part, this is a general audio synthesis with different inbuilt algorithms you are having, like simple melody. I have just talked about how you will optly provide it the simple melody, how you will provide the beating effects. Fine. Just take care of this. If you are increasing or decreasing the sound, like it could be 6.7 second, or it could be 8.5 second. So it will have a pause of that particular. Fine. Now it is taking a long pause. Can you see this? It is still going on and it is taking a long pause. I guess it's done. Yeah. Now, before getting into this, the same audio synthesis, the same audio synthesis, but with GNAI effect. Fine. GNAI inspired video, like you should use some sampling frequency of same, as you can see it over here. This is a different file you can see. Fine. Inbuilt video is there only, the chirp, gong, and train sound. It is there only in MATLAB. So you just need to upload it, upload the inbuilt audio. Now you have to provide some audio choices, like whether you are going for chirp, whether you are going for gong or train. So you have to load all these audios. Fine. Train whistle stored in Y, gong stored in Y, chirp stored in Y, something like that we could do. The first step was to normalize this inbuilt video, because we have to convert it into 2D model just to make your algorithm run over it. Fine. Then we have to do procedural blending with generated sine wave. Five. How it is working, how we will resampling it, how we will perform the pitch modulation. Fine. So all those things. So blending it with generative sine wave, the same generative sine wave formula is getting used, but the change we are making it that we are doing blending, like inbuilt audio and sine wave dynamically. So this particular code or this particular function is blending it dynamically, like it is open, that it could, something can be changed or some adaptability can be done, some dynamic environment can be provided, just like that. So before that, after going it to, we have to normalize and play, just to check it that whether it is going right or not. Fine. Now we are having pitch modulation, stochastic resampling. How we are performing pitch modulation, that random select any scalar vector and change pitch, append the output, and add silence between the iterations. I mean, you can do anything in between, before the iterations, after the iterations. You can normalize it and you can play the stochastic audio. You just have to pass this particular function. Fine. And now the same thing we are doing it, but with different approach. Now noise based modulation in built audio. Just look at over this and you will able to understand that what we are doing. Look at over this part only, before getting into generative chord progression based on input. Fine. Just have a look and I'm just explaining it to you. So we are doing this to modulate amplitude using slow sine wave, and it is very much available on the prerequisite part of the MATLAB inbuilt part. So we need to generate a random noise and we need to play the modulate audio. So we are doing this with this. Fine. Wait until the audio finishes playing. So I can understand that going through code and code will not able to make you understand, so I will explain everything, like without AI, Gen AI, what we are doing, and with Gen AI, what we are going to do. Fine. I just need to explain that how it is going to be done. So generative chord progression based input is getting performed for shift based frequency, random shift with one octave, or generate chord, or add silence at the same time, match the length. Generative audio you can play. See, here is the generative audio you can play. So how generative output is getting cleared, coherent generative output I have discussed with you. How generative AI inspired audio synthesis is getting completed. So we just need to save it, that this M file, and we just try to run it. Fine. Now we are having this particular file with us. Fine. So you can go for these three things. Sure. It's working. It's generative AI. Fine. Again, you have to go for gong with the particularly stay and take a pause, and again it is getting run. Fine. Again we have to go for train. See, take a pause. So we are having this particular function for using this MATLAB chirp, gong, and train sound, loading inbuilt video, but we are using generative AI inspired audio synthesis for inbuilt MATLAB audio. So what we are demonstrating dynamic blending, stochastic effects, and procedural synthesis using Gen AI. What we need to have, like neural network, we need to use. Fine. So these are the two techniques which we are having. So let me describe it. Ma'am, PPT is
Yeah,
uh,
visible, sir.
visual. Fine.
Yeah.
So let's start with what we have done and why we have done it. So we have reached to this stage. Fine. This we have done basically. Fine. Introduction to generative AI, learning from data. We have done it in the first slide. Creative potential. We have done it in the first slide. Generative AI empowers musicians and sound designer to explore new sound space and generate unique audio experiences. Emerging technologies like generative AI for audio synthesis is rapidly evolving, filled with exciting possibilities. And how it is getting done. Fine. The three things we did: waveform generation, signal processing, and sound design, with Gen AI also and without Gen AI also. So what we need to perform, as you can see it over here, we have opened it in a live script, and it could be performed at same as in the command window prompt. If we are doing it copy paste, it will also run like that. But what is the prerequisites we need when we are doing audio synthesis with MATLAB? How we will check the capabilities, like audio read and write. So MATLAB provides a function for loading, manipulating, and saving audio files. Second thing, we have to download the signal processing toolbox apart from MATLAB, and then it will integrate itself, and then we have to go for deep learning toolbox. I have downloaded it today only for this particular purpose. Otherwise, I don't need deep learning because I'm using it for AI ML, like image processing only. Fine. And it will not make any alteration in the configuration part, and it will not help you if you are having 16 GB RAM or more than 16 GB RAM. So what we have done and how we can discriminate it, like what we have done and what has been done before. So just let's have a look. This we have discussed it before. This is something which we need to discuss. Fine. How we will explain this. So use of neural concept only will make the change, will make the difference in the whole process. So as we can see on the slide, that data preparation, model training, and audio generations are the process. How it is getting done, we have just gone through with the code and all, how it is getting done, how it is performed. Fine. But how we can use the neural network concept to perform generative AI? So while the current generative AI inspired code, which we have discussed, AI inspired code, does not involve actual neural network. Fine. MATLAB doesn't inherently support the real-time synthesis. Let me tell you. You must all aware of it. So it mimics neural-based principles. What it could be like? It could be interpolation, it could be randomness, it could be dynamic adaptation. If it is not having dynamic adaptation, why Gen I we are using? So if it is interpolation, it will definitely simulates how neural model interpolates between parameters. For smooth transition, like dynamic frequency blending, we have just discussed it about. What is blending? Blending combine multiple waveforms with variable weight, similar to AI feature blending of creative outputs. Means combine multiple waveforms. Remember, so that is why we have taken waveforms. If you can see it over here, music composition and sound effects, waveforms. So first, you can see that waveform generation. What is procedural design? Means if you are using Gen AI inspired features, use algorithm and rule based approaches to build music dynamically. You know, it has to make that particular audio dynamically. It should have some AI driven creativity. It is not like before only. So what could be the randomness according to you if you are from electronics background? So add stochastic elements like AI sampling from distribution during generation, which we have added. Adding sine wave in the middle, adding square wave in the middle, adding white noise, long or short pause. Fine. So dynamic adaptation simulates like how AI generates texture, how it generates sequence that evolves over time. Getting my point? So this is what we need to discuss. This is what we need to have, like why Gen AI, why not the conventional AI? Fine. So the key feature I want to discuss with you, the key feature is predictability. The key feature is complexity. The key feature is AI simulation. So if you can see the previous code, let me get you back to the code part if you remember, because it will not that particular visible through that point. So if you can see the previous code, you know, so it is having high predictability rate, basic sound synthesis concept, which we have been doing since long, no AI related concept, simple formula, simple basic things, mathematical things we have passed, which is a very much classical approach, and it is giving the result. But when we have generated generative AI code, what was happening? It is dynamic, it is unique in each execution. We are trying to implement everything. If you will say, I'll discuss it again. It introduces advanced generative techniques for richer output. Remember how it is changing that particular thing. I mean, for the same input, for the same input data, they are generating a very different result. So it mimics blending and procedural logic and generative AI. Everything is getting mixed to generate results. So generative AI basically, the concept it has been used like the code blends that inbuilt audio, fine, lecture, gong, train, with generated sine wave and procedural modulation. Procedural modulation, what does it mean? Like random pitch shift, noise, chord progression. This mimics like how generative AI model can create new unique audio content by combining learned pattern, random, or you can use algorithm generated changes. So whatever we have done using algorithms, different algorithms, which is Gen AI or GAN is providing me. Fine. So for example, you can take like generative chord progression. We have made a code, a small function with chord progression. So it uses a random shift in frequency. And it uses random shift frequency for what purpose? To produce new musical combination dynamically. Anything can be changed in between. Fine. So just to provide musical combinations in video or audios using Gen AI is aptly justified with this. Fine. So dynamic blending and modulation is doing for what? So instead of static audio processing, the code using dynamic blending. Dynamic blending, what I have told you, that using many waveforms, combining many waveforms. So gradually blending inbuilt sound and with sine waves, every sine waves is getting integrated with FS. Fine. For um, modulation types we are using, so applying random scaling, pitch shifting. So these are inspired by generative method where a model or a system, you can say, produce novel output that evolve over time based on input condition. We are not aware of what is going to be generated. So if we are talking about noise based modulation, you know, so introduce randomness and variety, which are very common characteristics of Gen AI in music and sound synthesis. So this can be likened to the model that generate diverse output rather than repeating fixed pattern. So generative audio models like generative chord progression takes a base frequency procedurally shift to the create new chord. So that is why chord function is all about. Similar to how a generative model might learn to synthesize music or audio from the learned pattern or data set we are having. Fine. So the use of random shift and frequencies to generate new sound is inspired by neural network only. I have already told you we are totally based on the neural network and other AI models that can produce creative outputs by manipulating the learned data, which we are having with us. So that is what in the slide is there, data preparation and model training. If we are doing it efficiently, like the data preparation and model training, then audio generation can be instrumental. Fine. So why generative AI is used over here? Why we should use it over here? Just for the music composition and sound effects. Whatever we have gone through within the coding part or in the example part, it is done for the music compositions and sound effects. So Gen AI can assist composers in generating musical ideas, creating unique melodies, and how it is creating unique melodies I have just shown to you. Exploring new harmonies. Generative AI can create realistic sound effects for video games, movies, or other media, enhancing the immersive. So how we can explain it? Like this is just an example, but how we can explain it in a different way? So we can explain it in a different way by saying that creative audio generation. So if somebody will ask us that what is how we are creating audio generation, so generative AI helps in creating unique and dynamic soundscapes, right? Can we say like this? And that evolve in a real time. So traditionally, audio processing method typically manipulate pre-existing sound. We have used a video, which is inbuilt video, which is available with MATLAB. Remember, but generative model will always allow a new sound synthesis. This is the difference. Generative model will always give something like new sound synthesis based on what? Based on the learned patterns and rules. That is what application and use cases is all about. What is randomness and what is unpredictability? So by applying the processes like random scaling, I beg your pardon, random scaling, noises we have used, white noise or something like that, noise, pitch modulation. So the system can generate novel and unpredictable audio outputs, much like how generative model can create artistic work, what it is showing in the slide: music, image, text with varying degrees randomness. And in the sound effects, you are doing procedural synthesis. Instead of relying solely on stored audio clips, the code, the code introduces procedural synthesis. So, what is procedural synthesis? Generating sound wave and audio effect in a real time based on the basis of mathematical rule, classical techniques, or random parameters. We have used random parameters. Remember, the values we have used are random. I have changed it in the middle just to show you that it is working on the random parameter. Fine. So this is a hallmark. This allows endless possibilities now. This can be changed the total scenario which has been gone like before. So this is a hallmark of generative AI. That's what generative AI is all about. Fine. So the future direction could be like, what could be the conclusion and what could be the future direction. Once we will go through with it, we will cover it everything. I will discuss all the postulates with you again. Fine. So innovation, creativity, and future potential. So for this, real time adaptation is very much important. So we have to discuss real time adaptation. How we will discuss real time adaptation? So like many generative AI model adapt over time based for inputs, the audio blending and modulation technique in the code change in the real time, what we have discussed it just now. So making the sound creation process more interactive and adaptive to user inputs. Generative AI enhances audio synthesis. Fine. So in summary, we can say that generative AI enhances audio synthesis by introducing elements of creativity, at the same time randomness, and at the same time adaptability. So it moves beyond traditional and static sound effect and generates audio and evolve the real time. The audio that evolve in the real time, allowing for more dynamic and personalized listening experiences. So at the end, in the summary part, we are coming to know like it is more dynamic, versatile, more adaptive. If these three features are not there, it is as same as the previous AI. So if we are talking about innovation, generative AI for the audio synthesis is rapidly evolving field with the ongoing advancement in the model architecture and algorithm. So this is needed. Architecture should be improved. At the same time, algorithm will be improved in a way if we are improving architecture. Now, creativity, like generative AI empowers musician and sound designer to explore new sonic territories and create unique audio experiences. For example, many classic singers like before from different film industry, local, regional, or Indian film industry, we are having new songs on their own voices. You must have gone through with from, I mean, those on Facebook and Insta. Fine. So this is in summary means generative AI enhances audio synthesis with these elements of creativity and randomness. Getting my point? So that is what we are having to discuss now. Why we are looking for some future potential using generative AI. So what could be the endless possibilities? What could be the continued development? What could be the transformative technologies? These things we are having in our mind. So we must need to discuss that what could be the transformative technologies. Fine. So transformative technologies could be like, if we are talking about music composition, so data preparation using generic specific music data set. Suppose we have taken, just like we have taken a audio data set in MATLAB, then we are having a generative process produces melodies and harmonies in various style, and then we are having a very important step which is called post processing. Fine. We are having a post processing. But if we are talking about endless possibilities or continued development, so we must need to discuss real world use cases and transformative potentials. So AI powered speech to speech technologies is almost revolutionized now. Means voice harmonization software allows agents to optimize it, optimize the conversation part for the clarity, some distorted audio or something like that can be now optimized. It could be optimized before also, but now very much efficiently. So while suppose some SoftBank's emotion cancelling technologies like aims to reduce agent stress by calming angry customer voices. Getting my point? So these innovations focus on improving both customer and agent experiences. So the entertainment industries is leveraging this technology to expand creative possibilities. So voice actors can perform their voices from different characters, as I have discussed it with you, or languages, while historic figure voices can be recreated for educational content. This opens up new adventures for storytelling, immersive experiences in gaming and virtual reality, you can say. Generative AI in revolutionizing accessibility of, accessibility by crafting personalized synthesis voices. This lecture is all about synthesis. So synthesis voices allowing individual with speech impairment to communicate more naturally, and more expressions should be added. This technology also benefits language learner by providing interactive and more immersive educational tools, making language acquisitions more engaging and effective. Fine. So speech to speech technology or audio synthesis continues to evolve its application and likely to expand across various industries, not only to entertainment industry only. The potential of enhancing communication, creativity, and accessibility is vast. You know, so we could consider ethical consideration and challenges also, but we have to take care of these part first. Fine. So again, we have to come on the MATLAB part. So as I have told you, ma'am, the window is visible.
Yes, sir.
Okay. So as I have told you, like whatever we are running on the MATLAB part, we just need to show you, like suppose this thing we are having. So we are having audio M, and we have to generate it from there. So we just need to copy it, and we are having command prompt, and it is very much ready to use. So we just need to paste it. So even if you can run it by using this particular point. So command prompt is also supporting it, but it is taking a pause and then again it is started. This is the audio synthesis without Gen AI. Fine. This is the audio synthesis without Gen AI, and now we are having this is we are having. Fine. Now we are having that Gen AI file, which is named like. Just have a look over this. Gen.m is the file. So we just need to, if the command prompt is ready to use, we just need to copy paste. So it is having a API using here user interface. So we just need to click it for a single change. So choose an audio input from your side and you will get the result. See there. So what we do, we have loading inbuilt audio, we are playing inbuilt audio, blending inbuilt audio with generative sine wave, and then we are applying some pitch modulation process, then we are applying some noise modulation process. Gen AI audio synthesis completed, it is showing. Now again we are running it and we are going for gong. Fine. So again the same process is going to be done but for different inputs. We just see to it. Fine. Again, we are going to run, and now we are doing it for train. I'm just minimizing the sound. So it is for train. It will take a pause and again it will do the things. So this is what we are having for this particular part. So I'm again, let me check with the PPT part if anything is left from my part. Otherwise, I'm open to questions if you're having any. That's all from my side. Thank you.
Thank you for your informative session, sir.
Thanks.
Participants, if you have any queries, you can unmute yourself and you can ask or put it in the chat box.
So, Renisha ma'am, may I speak something?
Yeah, sure, sir.
Okay. So, anyone who are working
Ah,
on,
yes, madam. Yes, sir. I have
yes
a
sir,
question.
please.
Uh, can you tell me the how can I enhance the audio using generative AI?
Sir, as I have told you, we just need to focus on the neural network part. So once you are taking the input data, it is very much random data you are generating. So there are two phases, sir. Let me tell you. One, you are having a data set of your own, and second, you are using a data set which is in a generative AI approach. Suppose you are using a data set which is having a crowd scene over there. So you have just generated it by yourself. So you have to
Yes.
make it more normalized. You have to make it free from the noise. So cleaning and pre-processing is the most important part, sir. Once it will be done, again and again you have to keep trying, and you have to check with other algorithms with neural network, and then it will be increased most probably. But Gen AI is mostly getting done into audio synthesis and video synthesis
Oh,
and most
yes, yes,
textual
yes,
data,
sir.
finance and all. Yes, sir. But for
Thank you.
images and for all, these are not doing very well. Yes, sir.
Sir, can I ask a question? Another question.
Please.
In Google, Hello Google or Alexa, is there any function of generative AI?
No, actually, what happened, sir? Let me give you an example. When ChatGPT is being, came into full fledged, so
Yes,
we have asked it to get it done, like make it cite or something like that. So the citations has been given, which is totally faked, which is totally forced, which you will not able to found on Google or somewhere else. So you have to make sure somehow manually, right? In these days we cannot rely totally upon AI, not before, not now also, sir. So even
yes, yes.
Alexa is working on the learning data only, sir. So whatever
Uh,
we are making it learn, it will give answer accordingly, sir. It cannot
Thank you.
be full-fledged true. Yeah, thank you, sir. Thanks
Thank
for
you.
asking. So thank you, Renessa ma'am, for having me here, and thank you everyone for being patient and a very good listener.
Thank you,
Certainly, we
sir,
would.
actually, for us from our
Yeah,
side as well. On behalf
thank
of
you.
our entire organizing team, I would like to thank you for
Thanks
that
a lot, ma'am.
truly exceptional presentation and for your valuable time and for sharing your expertise with us today. Thank you so much, sir.
Thank you, ma'am. It's really honored for me, and thanks a lot. And I'll really want to join again with some other events. Thanks a lot, ma'am.
Sure, sir. Sure, sir. Thank you, sir.
Thank you. May I take your leave, ma'am?
Yeah, sure, sir.
Thank you. Thank you.
Participants, you can find your feedback link in the chat box now.
Share feedback with me, ma'am, in the latter
Sure,
phase.
sir. Sure, sir. I'll do
Thank
it,
you,
sir.
ma'am. Take care. Thank you.
Hello. Yes, ma'am.
as we have the examination at the end of the FDP, ma'am. So please share the PPTs with us also so that we
Yes,
can prepare for that.
almost, session 1 and 3 and are shared. Remaining, we are waiting from the resource person to share with us. Once it is done, it will be shared. And in the meanwhile, I'll be sharing you the